Hello, ladies and gentlemen. Welcome to yet another exciting lesson from SAGET Tech. My name is Joseph, and I hope you enjoy this one. And please don't forget to hit the subscribe button below this video for us to be able to keep producing more and more of these wonderful and exciting videos. Hello once more. Today we're treating Greek technology, grade 7. And our topic is electrical systems and control. We're focusing on electromagnets. Most importantly, we need to understand what electromagnets are. And we said electromagnet is a temporary magnet that is formed from electricity. You'd recall this from the previous lessons that I offered in this channel. And we as well explained that they will retain their magnetism only once current is flowing through the circuit, and immediately when you cut off the path of current, they lose magnetism, meaning that they demagnetizes. Now, we're going to be looking as to how do we create an electromagnet. Firstly, we need to look at the theory that we're going to use in order to create an electromagnet. Our theory says around any current carrying conductor, there is magnetism. We've got a conductor that is carrying current in itself. Around it will be having a magnetic field. Like that is the conductor. That conductor, you see those cycles around the conductor, they are called magnetic field. Now, when a current carrying conductor is wrapped around an iron core, that iron core becomes a magnet. It simply means that because I've already explained that a conductor that is carrying current have got magnetic field around it, this magnetic field are going to be deposited onto the iron core, making such an iron core a magnet, a temporary magnet for that matter. The iron core will retain magnetism only while current is still flowing through the circuit, and when we cut off the path of current, the iron core loses its own magnetism, and we therefore say it demagnetizes. Now, let's now make our electromagnet. There are a couple of components that we're going to need. The first component that we'll need is the nail, which is made from iron. You would recall magnetic materials are those that have got iron inside them. But then now we are creating the magnet. If we want a very strong magnet, we need an iron core. The second thing that we're going to need is a conductor. At this point in time, this conductor does not have current. Therefore, there is no magnetic field deposited onto the nail. And still just the nail, it does not have any characteristics of magnet until we connect a cell to our circuit. And now that the cell is connected, current will start flowing through the circuit. And as current flows through the circuit, our conductor becomes what we call a current carrying conductor, because there's current flowing through this conductor. And you would recall, as current flows through the conductor, magnetic field is formed around the conductor. And you see, this conductor is wrapped around this nail. Therefore, magnetic field that is formed around the conductor is going to be deposited onto the nail, and this nail will therefore change to become an electromagnet. It will become a magnet, and it possesses now all the characteristics of a magnet, because now it's converted into a magnet. But because it's only formed by electricity, and when you cut off the path of electricity, it demagnetizes, we therefore called it an electromagnet. This electromagnet of ours have got some characteristics, and one main characteristic that we're going to be looking at is the ability to attract magnetic materials. It of course have got other characteristics, like it have got its own south and north. It may repel, attract another magnet if brought closer to it, depending on the pole that is brought closer to any of the poles of this electromagnet. Now, this is what happens. Immediately when you put some pieces of iron in this regard, we've used the magnet clips, they are quickly attracted to the iron core when it is magnetized to show that this iron core is now a magnet. These are the pieces of magnet clips, the ordinary magnet clips that you use when that they use at the bank. Now, the issue here now is what happens when you want to attract many magnet clips or many pieces of ions, and our electromagnet is not strong enough to be able to attract the number of iron or the magnet clips that we want, and it can only take very few because of the strength of magnetic field that it has in itself. We must employ two methods, either of the two, in order for the magnetic field or the magnetism of this electromagnet to be very, very strong, in order to attract as many pieces of iron, or in this regard, magnet clips as possible. Now, let's check the different methods that we go. Remember, we only have got two. The first one that we're going to use is increasing the number of cells, thereby increasing current that's going to flow through the circuit. If the current goes high, the number of lines of force around the conductor increases, thereby increasing the intensity of magnetism on the iron core. Let's do that. Remember, we are removing the cell first, and as you remove the cell, the electromagnet demagnetizes. Therefore, our magnet clip falls off, and you now put two cells. Two cells meaning that current through the circuit is going to be increased, thereby the intensity or the strength of the magnetic field around this electromagnet of ours is going to be very strong, thereby attracting more of the magnet clips than it attracted before. You can see that now we've got many magnet clips attracted to this iron core. Now, this is the very first method that can be employed in order to increase the strength of magnetic field of an electromagnet. Now, we are now going to be looking into the second method that is employed in order to increase the intensity or the strength of magnetic field in the electromagnet. We first have got to go back to our initial circuit where we had only one cell connected to our circuit. You'd remember that we have very few pieces of iron or the magnet clips attracted to our electromagnet. Now, in order to increase the number of magnet clips that are going to be attracted to the magnet, we have got to increase the intensity or the strength of magnetic field. And the second method that we're going to use is to increase the number of turns. Let's first remove the pieces of irons, and then we increase the number of turns. You can see now the number of turns are so many. I am reading now 12 number of turns on this iron core or nail, as compared to the 7 turns that we had in the previous ones. Now let's see. It's going to be able to attract more and more magnet clips than it did before. That is the two methods that we're going to be using in order to increase the strength of magnetic field in electromagnets. Now, one important thing that we need to remember is that we cannot use pictures in order to represent different components in a magnetic circuit, just like we did in an electric circuit. We need to have symbols that we are using in magnetic circuit in order to represent different pictures. You can remember that we've been using a picture of cells and the picture of a nail, but then when it comes to circuits, we need to have appropriate and correct symbols for each and every component that we're using. So let's look at the circuit of the electromagnet. This is the circuit. When you look at the circuit, you can see we've got an electromagnet to your right, and on the left here you've got a battery which consists of 2 cells. But now, for the sake of the grade 7 curriculum, you'd remember that you have got to be able to close and open the path of current in order for you to magnetize and demagnetize this electromagnet. So let's put on our switch in order to be able to close and open the path of current. And they also ask you to have a certain way of showing or indicating that current is flowing to the electromagnet. And in the CAPS document, they say you must use a bulb. But then if you look at the syllabus once again, it tells us that the only electronic component that we're using in grade 7 is the light emitting diode. And this is the most appropriate component that can be used to indicate the presence of current in the circuit, as it is its duty. The primary duty of an LED is to indicate the presence of current in the circuit. And in this regard, we just want to know as to whether current is there in this circuit or it's not flowing. Therefore, I would suggest that we, instead of our light bulb, we put on our light emitting diode. There it is. There is our magnetic circuit for our, or the circuit diagram for our magnetic circuit. Now, in closing, I just want to show you different practical uses of electromagnets. We need to know why we learn a lot about electromagnets, because they are extensively used in our everyday life. The first practical application is in motors and generators. They use electromagnetic induction. Therefore, they need electromagnet inside in order for them to operate. You remember that in a generator, there must be a movement between a magnetic field and a conductor for that conductor to induce EMF or voltage inside it. And in the motor, similarly, for the shaft of the motor to start to rotate, there must be different in magnetic field in order for the shaft to rotate. Right. Transformers also are using the principle of electromagnetic induction. Therefore, they need electromagnet to operate. We also have the relays. We do have electric bells and buzzers which use electromagnets, or simply this principle of electromagnetic induction. We also have loudspeakers and headphones, all the magnetic recording and data storage equipment like your tape recorders, like your VCR, like your hard disks of a computer. They are using electromagnets. And finally, the magnetic doors like those of the refrigerators. You see, you can just push it and it automatically closes itself up because there is magnet that is being used there. And that marks the end of our lesson today. Thank you very much for listening, and I hope you learned a lot on electromagnets. Please don't forget to hit the subscribe button below, and you can also leave your comment or your question on this lesson so that we can explain further on the comment section. From me, Asaf, at SAG Tech, thank you very much.